Any old iron? Yes, scrap, acres of it. At one time, perhaps, an almost worthless commodity. Today, a valuable source of national and international wealth. Because of ever-increasing steel production, the demand for scrap has grown year by year and has recently attained a figure of 10.5 million tons. This dramatically demonstrates that much depends upon the efficient and economical gathering of scrap and transporting it to the steelworks. The purpose of this film is to highlight the part played by the Fielding hydraulic baling press in this work. Scrap is, indeed, a pressing problem. Today, everyone employed in collecting scrap fully appreciates the important place occupied by the scrap baler. We want now to show you something of the range and variety of Fielding balers, from the small baling press for the small scrapyard to the large baling press installed in the actual steelworks. Generally speaking, scrap is bulky, light in weight, and awkward to handle, meaning considerable expenditure of time, labor, and transport. The function of the baler is to compact this awkward material into a more easily manipulated mass. This diagram shows the various collecting points for scrap metal and the flow of the scrap from these points to the scrap yards, and after that to the steel works, where the scrap takes its rightful and important place in the production of new steel. This baler is the smallest of the Fielding range. It is of the double-action type, having a swinging or alligator cover. The press is a self-contained unit, complete with hydraulic oil pump equipment. The baler can be re-sighted with a minimum of effort. Now for the baler in action, compacting non-ferrous waste at McKechnie's Works, Birmingham. Here it is being hand-filled, as is generally the case with this small baler. But of course, conveyor or hopper filling could be incorporated if the type of material justifies it. Filling completed, the alligator cover is lowered hydraulically, compacting the material and closing the box. At the same time, any material which may be spreading over the edge of the box is sheared. Note the convenient position of the control panel. The main pressing head at this stage now moves forward under hydraulic pressure and will continue to do so until full power is built up. The material is then fully compacted. Compacting completed, the door opens hydraulically and the bale is pushed out by the pressing head, now used as an ejector. With the bale clear of the box, the end door is closed and the pressing head withdrawn to the commencement of its stroke. Here is a larger size of Fielding standard baler, the SCB2. The baler is again of the double-action type, similar to the SCB1 previously shown, and this is the size most commonly used in scrap merchants' yards. The press is of the self-contained type, complete with hydraulic pumping equipment, again using oil as the pressure medium. Re-sighting can be accomplished with the minimum of effort. Two SCB2 balers are installed at J&HB Jackson's, Coventry. The end door of an SCB2 is now being opened. The bale is pushed out by the compression head, as in the case of the SCB1 baler. This particular unit is manually operated, but the baler can also be provided with a hydraulically operated door actuated by remote control. Here the baler is loaded with general scrap. Hand-loaded in this instance, hopper or conveyor loading would be introduced if the material warranted it. Here, hand-loading is obviously more convenient. Now the second baler is seen being loaded with stamping scrap, and when the loader decides that sufficient material has been introduced, the alligator cover is set in motion, closing the box, and, as in the case of the SCB1, giving an initial compression to the scrap in the box. The operator opens the door, and the bale is ejected by the pressing head onto a roller path which carries the bale clear of the baler. From the roller paths, the bale is then manually pushed onto a conveyor, carrying the bale over the scrapyard to a convenient position for loading onto suitable transport. This is a good example of mechanical handling equipment in a scrapyard. The alligator-type box cover acts as a hydraulic shear. This shearing arrangement is very successful where corrugated sheeting is being baled. Now for the largest baler of the Fielding standard range, the SCB4. It differs from the others mainly in size and power. The average weight of the bale produced is 300 to 4 hundredweights. The pressing cycle, excluding loading and unloading, being approximately 2 minutes. This type of machine is in the larger scrapyards and in factories baling their own scrap. Now watch the baler in action at the South Wales Aluminium Works of ICI. The baler is being filled with light alloy scrap. Once again, filling is by hand. Mechanical feed not being justified in this particular application. Note the safety measures incorporated to protect the personnel in the event of flying pieces of scrap which may occur during the shearing operation by the lid. This is the hydraulic pump and supply tank providing the hydraulic pressure medium. When compression is completed, the hydraulically operated end door is opened and the bale discharged from the box by the compression head. After ejection, the alligator cover opens and the sheared scrap falls clear following the opening motion of the cover. Recharging of the baler box is then commenced and the cycle of operations repeated. Here are various products of this baler. A bale made up of light alloy swarf, another of 1/4-inch thick alloy sheet, a third of alloy tubes, and finally one of 16-gauge alloy sheet. Note the neat appearance of each bale. Now for machines used in the larger type of scrapyards or in factories baling appreciable quantities of their own scrap. This machine, for example, is a treble action baler. It has a rolling type cover, wedge locked on a bridge built over the final compression. The first compression head moves longitudinally along the box to a predetermined distance from the pressing end of the baler, after which a compression head moving at right angles compresses the metal to a predetermined position. The final compression head moves from the bottom of the box upwards, and the extent of movement depends on the quantity of scrap loaded into the box at the commencement of the operation. The average weight of bale from this press is normally about 600 weights, with an overall time cycle of 78 seconds for the actual baling of the material. The Fielding baler shown is installed at the works of the Pressed Steel Company Limited of Cowley and is being charged with scrap from a tipping truck. The cover is hydraulically operated. Here again, the baler is being filled, this time with scrap car body parts. The cover, in addition to closing the baling box, also pushes clear the previously made bale. After completion, the bale is held in a position to enable the cover, when closing, to push it clear of the machine. An electromagnet lifts the bale onto a lorry for dispatch. Note the variety of scrap and bales loaded. A view from the control panel. Correct positioning is essential with every installation. This particular type of baler will be shown installed in the works of the Austin Motor Company at Longbridge. Though similar to the one previously shown, the installation of the baler is quite different, as are the means of loading, discharging, and carrying away the finished bales. The loading of the baler is by factory hand trucks. 2 or 3 fills from the hand truck may be necessary to charge the baler completely. A truck tippler arrangement is employed and so balanced that when the truck is empty, it returns to the unloading position. A close-up shows the truck tippler gear in greater detail, also the safety guard surrounding the baler box. When the tippler moves to a position ready for the empty truck to be run clear, the box cover rolls forward. As before, the cover again pushes the ejected bale clear of the machine. Note the relationship of the control panel to the baler. Here, part of the press control valve gear is in operation during the pressing cycle. This secondary compression ram moves up in every case to a predetermined position in the box. Now the final compression ram moves into the box, the extent of movement depending on the amount of scrap initially charged into the baler. The baler cover opens. At the same time, the final compression ram lifts the bale up clear of the top of the box, holding it in a position suitable for pushing clear by the cover. The cover pushes the bale onto the ramp. The bale passes down the ramp from factory floor level to a point where the bale is discharged from the ramp onto the railway wagon. Labor is needed now to ensure tidy loading of the bales into the wagon. As each wagon is fully loaded, it is moved clear. Another empty wagon is brought into the bale discharge position. Let us examine now balers of the type installed in the main steelworks of Britain. These are generally of the double action type, but having a preliminary compression on the scrap by the alligator cover. They might be referred to, in fact, as triple action machines. Balers of this size are usually charged from one or sometimes two charging hoppers, so that the minimum time is taken to reload the box when the finished bale is ejected. Note particularly the type of ejection employed, the bale being discharged from the side of the box instead of the end. Here the baling press hopper is being loaded with scrap from a grab crane at Stewart's and Lloyd's. With the hopper loaded and the baler in the open position, the hopper is then tipped by hydraulic means, discharging its contents into the baler box. The hopper then returns to its receiving position and the massive hydraulically operated cover closes. During this closing motion, it shears any scrap which may be lying over the edge of the box, and at the same time gives an initial compression to the material. A close-up of the cover operating mechanism gives some idea of the power required for the shearing and compression of the scrap. In the control cabin, the operator is comfortably located in front of the controls. He also has an excellent view of the baler box. The final compression ram moves forward into the box until maximum power is attained, which signals completion of the bale. Particular care is taken to ensure adequate guiding of this ram, which is provided with sufficient stroke to eject the bale. On completion of the bale, the door is opened by hydraulic power and the bale is ejected from the box by the final compression ram. The bale is ejected direct to the furnace charging boxes, which rest on separately designed bogies. In this particular installation, the bogies are hydraulically moved a given distance, and at the completion of each machine cycle, an empty charging box is positioned to receive the next bale ejected. This arrangement eliminates the necessity for the constant use of a locomotive. The hydraulic bogie moving equipment is, in fact, of sufficient power to move a complete train of bogies. Only when a complete train has been loaded is a locomotive required to move the train from the baler to the furnace. This diagram shows a similar baler, but with still larger box dimensions. The unit is installed at the New Abbey Works of the Steel Company of Wales. The baler has a combined total hydraulic power of 1,275 tons. The hydraulic medium here is supplied by a battery of Fielding horizontal 3-throw reciprocating pumps having a combined horsepower of 400. It will be appreciated that such a machine must be of massive and practically unbreakable construction in view of the heavy-duty conditions under which it operates. This general view of the baler and control cabin is taken from one of the two huge electric cranes at Margam and gives some idea of the layout of the installation necessary to handle the enormous quantity of scrap for baling. The baling press hopper is loaded with scrap from the dumps by means of massive grabs operated by traveling cranes. The hopper of this model, one of the largest ever made by Fielding and Platt, has enormous capacity, and the press is able to deliver a bale of approximately 25 hundredweights. When the hopper is filled, the baler opens to receive its charge. The hopper is then hydraulically tilted, transferring the scrap charge from the hopper into the baler box. The hopper then returns to its filling position. Here is a view of the cover operating mechanism from the back of the baler. Note the massive construction. Now the hydraulic equipment drives the final compression head. When the ram comes to a standstill, the bale is complete. At this stage, the hydraulically operated door at the opposite side of the box is opened. Further forward movement by the ram ejects the bale. The tie rods connecting the final compression cylinders to the baling box can be seen. In this shot, the hydraulically operated door at the opposite side of the baler is seen opening, the bale moving out under the influence of the final compression head. In this instance, the bale is ejected onto a skid rail. On final ejection, the bale lies alongside previous bales. In this position, the bales are moved along the skid a given distance by means of hydraulically operated pusher gear. Here, the pusher unit is in operation. And now, finally, let us return for a moment to the Fielding and Platt works in Gloucester, where custom-built machines run hand in hand with many standard models. Before leaving the works, all presses are run and tested. They are erected in the fitting shops to ensure that all working tolerances are correct and that all pumps and hydraulic control valves fully carry out their purpose and speeds of operation according to predetermined calculations. Thus, there is the minimum of delay in commissioning the baler when it is delivered to the customer's site. Rigorous works testing also ensures that the various types of scrap can be actually tried out in the machine before installation. In short, as we have tried to show, Fieldings have done everything their wide experience dictates to ensure that their baling presses provide a complete, efficient, and economical answer to the pressing problem of scrap.